Hey guys, what's up? So today we're going to be looking at operations with fractions. Okay guys, so a fraction is a number written in the form n over d, where n, right, this n here is called the numerator, and d, this d here, is called the denominator. Okay guys, and n and d are elements of the natural number set, cool, which is the counting number set, which is 1, 2, 3, and so on, right? All right, guys, so we're going to look at the first type, case 1, the first type of fraction, and they're known as vulgar fractions or common fractions. Okay, so the definition says a vulgar fraction or a common fraction is a fraction which is a part of a whole. That is, it is less than 1. Okay. All right, so let's look at some examples here. We have a full circle here, but we can see that there's a line between this circle. So the top here is a half of that circle, and the other here is a half of the circle, right? So we can see here that this section of the circle is a vulgar fraction or a common fraction, which is a half, right? Now this part of the circle, let's look at this second circle here. We can see that this is a quarter of the circle, right? A quarter of the pie, right? All right, guys. Cool. So we can see here that one section here within this circle is 1 over 4, which is a common or vulgar fraction, right? Okay, so let's look at this one. This one here, we have 8 slices here, right? So it's actually set up sort of like a pizza, right? Right, so it's cut into 8 slices, and if this was a pizza, 8 persons would be able to get a slice, right? So we can see here this is 1 over 8, 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 and 1 over 8. Okay, so there are 8 slices here. Okay, so it's 8 slices of pizza. All right, so we can see that one section of this circle here is 1 over 8, right? So this is known as common, right? Common fractions. Okay, guys, and we're going to be looking at some examples. Awesome, guys. All right, so let's look at this example, guys. We have a square here, and as we can see, it's divided into 3 sections. So we have one section here, we have a second section here, and we have a third section here, right? So we can clearly see that the third section is equal to a half, right? So let's call it 3 here. The third section is equal to a half. Why? We can see from here to here would be a half of this rectangle, right? And it's in 3 sections, okay? All right, so let's move on to this one. This one is actually in 1, 2, 3, 4, and 5 sections, okay? And if we observe, we can see that this section, number 1 here, would be a quarter, okay? So this is a quarter. This is also a quarter here. This is also a quarter here. And this quarter is divided in 2, okay? So because this quarter is divided in 2, this here would be 1/8 of the rectangle, and this here, 5, would also be 1/8 of the rectangle, okay? All right, so let's look at the other section now. We have another rectangle here, and we have 1, 2, 3, 4, 5, 6 parts here. And from just observing, we can see that this 2 is a quarter of the rectangle. This 5 is also a quarter of the rectangle, right? Now these quarters here are divided into 2, so this would be 1/8 of the rectangle. This would also be 1/8 of the rectangle. This would also be the same, 1/8 of the entire rectangle, and this would also be 1/8 of the entire rectangle. So let's add up these, all of them, right? 1/8 four times, so that's 1/8 plus 1/8 plus 1/8 plus 1/8, right? Plus the 2/4, which is plus 1/4 plus 1/4. And let's see what we get here. So these four 1/8s would give us 4/8 plus 2/4. Okay. All right. So in order to find this, we'll have to find the lowest common multiple between 4 and 8. And the lowest common multiple is clearly 8, right? And we're going to get 4 plus 2 times 4 would give us, no, 2 times 2, right, would give us 4. So we'll end up with 4 plus 4/8, which is 8/8, right? Which is what we're supposed to get, which is 1, which is this 1 represents the entire rectangle. Okay? All right, guys, so great. So this is the first introduction to fractions, and we're going to move on to improper fractions now. Awesome, guys. So let's look at case 2, which is improper fractions or top-heavy fractions, okay? I prefer improper, right? So an improper fraction or top-heavy fraction is a fraction that has more than a whole. That is, it is greater than 1, okay? All right, so let's look at this example. This here is a full rectangle, right? So this would be considered a whole, right? Which is 1. Cool. Now let's look at this here. This would be considered about half of a rectangle. So this is 1 plus a half, right? Which would give us 2/2 here, which is the 1, right? This one is equal to 2/2 plus the half, right? Plus the half here, okay? Which would actually give us 3/2. Cool. So this 3/2 is what we call an improper fraction or a top-heavy fraction. Notice the 3 is bigger than the 2 here, so that's why they call it top-heavy. You know, think of a swimmer who has this like super big chest, and his legs are like always short, always smaller than his upper body because he uses his upper body to swim, right? It's similar to this in terms of the 3 is always the top number is always bigger than the 2. Cool. So that's why we have 3/2 here. Cool. All right. So let's look at the other example here. Okay. Let's look at the 2 circles down the bottom. All right. Let me just put 2/2 here. All right. So for this circle, it's the same thing. We'd have 2/2, right? And this circle is also 2/2. And this is half of a circle here, so let's call this a half, right? And we're going to add all these 3. So we're going to end up with 2/2 plus 2/2 plus a half. So 2 plus 2 plus 1 would be 5. So I'd end up with 5/2, which is also top-heavy or improper fraction, right? So that's basically what an improper fraction is. All right, guys. The top is always bigger than the bottom. And this is how we represent an improper fraction. Okay. All right, guys. So let's move on and let's do some examples. All right. All right, guys. So we went through the 2 types of fractions, which were common fractions, right? And improper fractions. Okay. Right. Okay. And remember, common fractions are like that example here, 3/4. 3/4 is a common fraction. And an improper fraction would be like 9/4. Okay. All right. So let's look at these examples here, guys. And we have some info up here saying in simplifying fractions, it is necessary to find the lowest common denominator, LCD, or that is, i.e. means that is, the lowest common multiple of the denominators. So we'd actually have to find the lowest common multiple for 4 and 5 in this example, okay? All right, so let's simplify this example here. We have 3 over 4 plus 1 over 5, okay? So the first thing we want to do is we want to find the lowest common multiple of the denominators, right? So let's just draw a line here, and this line represents the dividing line, right? Then for the two numbers 4 and 5, I'm actually going to use the lovely method because I want you guys to get used to that, right? So we're going to divide this 4 and 5 by the prime numbers, right? 2, 3, 5, 7, 11. Cool. So we'll always start with 2, all right? Remember the lovely method that we did earlier. And 2 divided by 4 would give you 2. 2 can't go into 5, so that just leaves 5. 2 goes into 2 again would give us 1, and then 5. Then can 2 go into 1 or 5? No. Can 3 go into 1 or 5? No. Can 5 go into 1 and 5? Yes, it can. 5 can go into 1 and 5. Cool. All right. So we end up with 2, 2, 5. So to find the lowest common multiple, all we have to do is multiply these three numbers. So it's 2 times 5, which ends up being 2 times 2 gives you 4, and 4 times 5 gives you 20. So 20 is the LCM, okay? So we'll have to find the LCM of the denominators, okay, in order to solve fractions. So we end up with 20 here, right? And in order to get the numerator, right, whichever is on top, for 3 over 4, we're going to end up with 3 times 4 goes into 20 5 times, okay? So we'll end up with 4 going into 25 times, and we'll have 3 times 5 as the numerator for this 3 over 4, which makes sense, right? Because 3 times 5 is actually 15 over 20, which is the same thing as 3 over 4. If you divide through by 5, you should get 3 over 4, right? If I divide 5 into 15, I get 3, and 5 into 20, I get 4. So it's 3 over 4. So that's why I have the 3 times 5 here. And then we're going to add that 3 times 5 to the 1 over 5, which 5 goes into 24 times. So you're going to end up with plus 1 multiplied by 4. Okay? All right, guys. So we're going to end up with 15 plus 4 over 20. Let's just remove this here. All right, and the answer is 19 over 20. So this is the answer. All right, guys. So let's move on to the next one. And for the next one, we have 4 over 7 minus 1 over 3. So we're going to do the same thing. We're going to try to find the LCM again. Okay, so let's use the lovely method again, right? 3 and 7 here. Cool. Now and let's write the same numbers here. 2, 3, 5, 7, 11. Can 2 go into 3 and 7? No. Can 3 go into 3 and 7? Yes. So we're going to get 3 divided by 3, which is 1. 3 can't go into 7, so it just leaves 7. Then 7 here would give us 7. Right, 2 can't go into 7, 3 can't go into 7, 5 can't go into 7, so we're using 7 into 7, which would give us 1, 1. And we'll always finish with 1, 1 here with the lovely method. And to find the LCM, all we have to do is multiply 3 by 7, which is 21. You notice, though, that to find the LCM here, all we had to do is multiply 3 by 7. So that's just a little shortcut there. Sometimes that's all you really need to do to find the LCM, but not all the time. Okay, guys? But just picking your brain there. So let's draw a line again. And 3 times 7 should give us 21. Right? Then we're gonna do the same thing. 7 goes into 21 3 times, right? So it's 4 times 3 minus 3 goes into 21 7 times 1, this one here, multiplied by 7. So we're gonna end up with 12 minus 7 divided by 21, which is the same thing as 5 over 21. Cool. All right, so let's move on to the next two. So we did A and we did B. Let's look at C, okay? So we'll have 8 over 9 multiplied by 3 over 4. All right, so for this one, there are two ways we can approach this. We can multiply the 3 and the 8, okay? So we'd get 8 multiplied by 3 over 9 multiplied by 4, okay? And that would give us 8 times 3 would actually be 24, and 9 4 is actually 36, right? And then we can cancel out. 12 can go into 24 2 times, and 12 can go into 36 3 times, which would give us the same thing as 2 over 3. So we can do it that way, and that way is cool. I'm gonna put or here because you can do it another way. You can just cancel the like numbers. So here we know that 3 can go into 9 3 times, so it'd get 3 here, and 4 can go into 8 2 times, so it'd end up with 2 over 3, right? So let's do it that way. 8 over 9 multiplied by 3 over 4 would give us 4 into 8 goes 2 times, 3 into 9 goes 3 times, so it'd end up with 2 over 3. Okay, I prefer this way. All right, I prefer to cancel out things first and then find my answer. I think it's much more convenient, but you can also do it this way as well. Okay. All right, guys, so let's look at the last example here for D. And for D here, we have 4 over 9 divided by 2 over 3. We know that when we divide, you flip the right side, right? So the 3 ends up over the 2, and then the multiplication, the division sign turns into a multiplication sign. And I'm going to do it this way, right? The second way here, instead of multiplying the top and the bottom. So I'm going to cancel this 2 into this 4, and I'm going to get 2. And I'm going to cancel this 3 into this 9, and I'm going to get 3. So it's going to be 2 over 3 is the answer. Okay. All right, guys. Okay, so let's do one last example before we move on to more complex fractions. Okay. So the last example here is we have a question saying simplify 1 over 3 of 24, right? So remember, of is the multiplication sign, okay? So of and multiplication are the same thing, all right, guys? So let's work this out. We're going to end up with 1 over 3 multiplied by 24, okay? So we can do it two ways. We can multiply the top to get 24 times 1 over 3. And then we divide 3 into 24, which would give us 8, okay? Or you can just cancel it straight. You can just say 3 into 24 gives you 8. Then 8 times 1 would give you 8, okay? All right. All right, guys. So please do the worksheet, and I'll see you in the next lecture. All right, guys. So that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.